An antidifferentiation example. Find the antiderivative of each of the following. Okay, well, x to the 4. So we could have a guess at x to the 5. And we know that if we differentiate that, that would give us 5x to the 4. So it might be a good guess that if we have 1/5 of x to the 5, when we differentiate that, 5 times a fifth is 1, and we just get x to the 4. So if we anti-differentiate x to the 4, it seems that we should get 1/5 x to the 5, since when we differentiate that, we get x to the 4. What you always have to do with this is add a constant, because when you differentiate, any constant would disappear. Now let's think about e to the 3x. We know how exponentials differentiate, so let y be equal to e to the 3x. Then dy dx would be 3e to the 3x, because we have to use the chain rule. So that's more than we want, but if we had to let y be equal to 1/3 of e to the 3x, when we differentiated, we would have got exactly 3 to the 3x, because when we multiply by the 3, it cancels with the third. So it seems that 1/3 e to the 3x plus that arbitrary constant would be the antiderivative of e to the 3x. If we differentiate this, we get this. So finally we've got 1 over the cube root of x, which remember is 1 over x to the 1/3, which is x to the negative 1/3. So let's let y be equal to x to the 2/3. Then dy dx is going to be 2/3 of x to the negative 1/3, which is not quite what we want. What about letting y be equal to 3 over 2 x to the 2/3? When we differentiate that, 2/3 multiplies the 3 over 2 to give us 1. So we would just get x to the negative 1/3. It's exactly what we want. So this looks like the antiderivative of this. So we're going to say 3 over 2 x to the 2/3 plus a constant. And perhaps since it was given in radical form, we need to give it back that way. So I'm going to say it's 3 times the cube root of x squared divided by 2 plus a constant.